Okay, so today what we're going to be working on is dividing polynomials. So what I would like you to do is do the try this. It says perform the indicated operation. So we are dividing. So I want you to think back about when you divide the same variables, what do we do to the exponents? So give it a try and I'll come back and check your answers. Okay, so when you divide, you actually subtract the exponent. So if you have the same variable, which is also called a base, you subtract the exponent. So we have x to the third divided by x squared. So you see we have the same base. They both have a base of x, right? So when they have a base, same base, subtract the exponents. If there's a coefficient, you would divide or reduce the coefficients. All right, so x to the third divided by x to the second. 3 minus 2 is 1, so this would be x to the first. But remember, if you don't actually have to write the 1 there, because if there's no exponent, we assume that it's 1. All right, number 2, we have x to the fifth divided by x to the third. That would be x to the second. 5 minus 3 is 2. All right, so let's write this down. So when we divide monomials, you either divide or reduce coefficients. And then if you have the same variable, which is also called a base, you subtract exponents. Okay, so let's take a look at number 1. We have here all right, so I have 15x to the fourth divided by 3x to the third. So I have my coefficients are 15 and 3, so I can divide them. They actually divide nicely, so 15 divided by 3 is 5. And then I have x to the fourth divided by x to the third. Subtract the exponents, same base, right? They're both base x. So x to the fourth divided by x to the third would be x to the first. So it'd be 5x. Okay, number 2, we have 18 x to the ninth y squared divided by x to the fifth y squared. So I have a coefficient in the numerator but no coefficient in the denominator. So we're just going to leave the 18 as it is. Then we have x to the ninth divided by x to the fifth. It'd be x to the fourth. Now notice here, I have y to the second divided by y to the second. So you have the same exact thing. Anything divided by itself, remember, is always equal to 1. Everybody wants to say, oh, they cancel. Well, they don't really cancel, because if they canceled, then you would get 0. But it's not 0. It actually reduces to 1 and 1. But we don't actually have to put the 1 down, because if I put the 1 down, it's going to look funny. You only have to put the 1 down if there's no other number to write. Okay, so let's take a look at number 3. We have 2ab to the fifth divided by 2ab to the fifth. So notice I have the same exact thing in the numerator as the same exact thing in the denominator. So this whole thing reduces to 1, right? Anything divided by itself is equal to 1. All right, so let's take a look at dividing polynomials. All right, so we have here, let's write down some steps here. So you're going to separate each term in the numerator. Remember, the numerator is the top. And put it over the denominator, which is the bottom of the fraction. Okay, and then you'll have a monomial, then you'll have a bunch of monomials divided by a monomial. So then you just divide each piece. Okay, so let's take a look at the first one. We have here 4a minus 8 divided by 4. So I'm going to take each term in the numerator, the 4a, and put it over the denominator, minus 8 over 4. So look, I took the 4 and I separated it like that. So we have 4 divided by 4 here. So it just becomes 1, right? That reduces to 1 and 1. There's no a in the denominator, so it's just 1a minus. And 8 divided by 4 would be 2. So my final answer would be a minus 2. All right, number 2. So we have 2ax to the third. Put that over 2x. Plus 4bx over 2x. All right, so the 2 and the 2, they reduce to 1 and 1, right? Because anything divided by itself is 1. I have an a, but no a in the denominator, so put the a down. X to the third divided by x, remember there's really 1 there. X to the first, that would be x to the second. Positive 4 divided by 2 in the next term would be plus 2. We have a b, but no b in the denominator, so bring the b down. And then x and x, they reduce to 1 and 1. So I have ax squared plus 2b. All right, let's take a look at number 3. Okay, so number 3 we have here 3t to the third over 3t minus 9t squared over 3t plus 12t over 3t. All right, so the 3 and the 3 reduce to 1 and 1. And t to the third divided by t to the first, right, because there's no exponents, really 1, is t to the second. If you want to put 1t to the second, that's fine. Negative 9 divided by 3 is negative 3. T to the second divided by t to the first would be t to the first. Positive 12 divided by 3 is positive 4. And t divided by t is 1. So it's just 4. All right, let's take a look at number 4. So number 4 is, we have 24 x to the fourth y squared over negative 6x squared y plus 18x to the third y to the third over negative 6x squared y minus 6x squared y divided by negative 6x squared y. Okay, so let's start with the 24 and the negative 6. 24 divided by negative 6 is negative 4. X to the fourth divided by x squared is x squared. Remember, subtract those exponents. And then we have y to the second divided by y to the first is just y. Okay, on to the middle terms. Positive 18 divided by negative 6 is negative 3. X to the third divided by x squared is just x. And y to the third divided by y is y to the second. All right, let's take a look at this last term. Notice I have negative first divided by a negative is going to be a positive. So let's put that down. And then notice I have the same exact thing. 6x squared y divided by 6x squared y is going to be 1. And it's positive 1 because I have a negative divided by a negative. All right, let's take a look at the last problem. Okay, this looks good. All right, last problem here. So we have 6p squared q r squared over 12p q r squared minus 2p q squared r to the third over 12p q r squared. And then we have minus 3p q to the fourth r squared over 12p q r squared. All right, so it looks like a lot, but, we just take it a little bit at a time here. All right, so let's start with the 6 and the 12 here. 6 divided by 12, that reduces to 1/2. Right, 6 goes into 6 once, into 12 twice. So that's 1/2. P to the second divided by P is P. Q divided by Q is 1. Anything divided by itself is 1. R squared divided by R squared is 1. So these are just 1s. All right, so let's go to the middle now. We have here negative 2 divided by 12. That's negative 1/6, right? 2 becomes 1, 12 becomes 6. That's negative 1/6. P divided by P is 1. Q to the second divided by Q would be Q to the first. And R to the third divided by R squared would be R. And the last one, we have -3 divided by 12. So that reduces to 1/4, right? 1 and 4. So it's -1/4. P and P reduce. Q to the fourth divided by Q is Q to the third. Then R squared and R squared, they reduce out to 1, 2. So that would be my answer. There's one thing I do want to show you, because I really am a big believer in showing you different ways you can represent the answer. So remember, this P, if I wanted to write this P here, this guy here, or the Q and the R, or the Q to the third here, as a fraction, that would be P over 1. So this could be written as P over 2. And then the middle term here would be minus QR over 6, because this would be over 1, right? So the 1, these would match up, and these would match up. And then it would be minus Q to the third over 4. Because this is really a 1 in front, right? So the 1 in the front here, this becomes the 1/2, the 1/6. There's a 1 here, so it's really 1/4. Okay, so just another way to see answers. We should always be aware of other ways to can represent answers, especially when things are multiple choice. Okay, so that's it. I will see you guys soon. We'll practice some more. Have a good night.